All right, let's take a look at one more path type algorithm that's a simple variation of what we were just looking at. What I'd like you to do is modify the path finding algorithm that we've been playing with to find the average of the shortest path distance to each reachable node. So that'll give, for some node v1 that we give to the program, it'll give us a measure of the centrality of v1. Okay, here's the code that we left off with. Let's make some modifications to this to compute this centrality measure. Program path g v1 v2 was returning the distance between v1 and v2 in the graph, or false if the two nodes were disconnected. We don't really need that anymore. What we really need is this centrality concept, and that really is done with respect to a single starting node v. And we're going to do basically the same search as before. We're just not going to terminate when we hit an ending node because there isn't an ending node. So we start off distance from the start state v as being 0. Once again, we go through our open list, pull the first element off, that's the current node that we're working on, pop it off the list. We look at the neighbors of that node. If this neighbor is a new neighbor, then we make a note of its distance, which is the distance from the start to the node where we just were, plus 1 to get the distance to the neighbor. And then we put it on the open list. We're going to take out this line where we stop the search. And what are we going to return at the end of all this? Well, once this loop is finished, once the open list is exhausted, we've visited all the nodes that were reachable and put their distances from the start state into this data structure distance from start. So now what we really need to do is average all these values in distance from start. So there's a lot of different ways that you can do this, but Python gives you at least one way that's very succinct. So I'm going to use that. You could also do this by setting up your own loop. But what I did in this case is I take all the values in the distance from start data structure, get them returned as a big long list, sum up all the elements of that list, add 0 to it, 0.0 to make sure that it's a floating point number, and then divide by the number of nodes for which we got a distance. So these are all the reachable nodes. So ultimately, this is going to return the average of the distances over all the reachable nodes, which is what we're looking for. Let's make one little change here, and we should be good to go.